Okay, here we go. We're taping 6 hour. This girl doesn't have her notebook out. Not ready. Okay. Um, correlation. Can everyone say correlation? All right. I remember looking at a standard normal curve back. I think it was in one of those 5 videos, and they took a lot of data point values. Um, and the data point values were when they graphed them, really grouped in the middle. That's for that, those percentages to be true in a standard normal curve. But when the relationship was graphed, it was a linear relationship. So I'm trying to think what is the correlation between looking at this correlation coefficient compared to what we're doing, because the variable is a little bit, I'm sorry, the formula, what I mean to say, is really strange. But I will say this: those that were in CAT, raise your hand. Meow. CAT. And in Algebra 2, I think maybe in the Math 1 through 3 program, you did what was called regressions, which you had a series of coordinates, and then you tried to mirror or match an equation to those coordinates, right? Okay, so you did do that. But then what you wanted to do, and I did this year with CAT a little different, all the CAT teachers. We actually made it more complicated where here's just a whole bunch of data. What type of model would work? Linear, quadratic, cubic, ln, logarithm, exponential. And the analysis behind that was at least introductory, what we're doing today. What the calculator does, it gives you a coefficient to tell you, does that model match that data or not? So I've seen this formula before, but I glanced at it. I knew kind of what it meant, and I'll share that with you later as we look at this complicated thing. It's weird. Okay, I always call the x value the independent, which everyone does. It's usually the input. Y is called the dependent or output. So usually, like a lot of times, the x values are time, and then after time, we see these y values result, whatever the situation is. And then just moving on, you could take the data that you see and then plot it. Okay, we're going to keep it linear right now, so don't worry about what I said about what we did with the CAT students. Maybe we can worry about that later. You don't have to write it down. A student almost fainted. Okay, this is right out of the CAT book, though. Exact same pictures that we shared last year with you in the beginning of the year, school year, August, September. Here's the idea. I look at data. Let's pretend the x-axis is like time, 10, 20, 30, 40, 50 seconds. I don't know. And then we analyze something. Let's pretend 10 through 50 is like meters traveled or something, some sort of objects that we're looking at. And then we plot it. Well, this first one in the left, far left, is it perfectly linear? Do all the points fall in a perfect line? Yes or no? No, it's not perfect. Remind me, and hopefully I remember to say this, when we talk about the correlation coefficient, if it was perfect, then R, which is our correlation coefficient, would equal something. Actually, this one would be 1 if they were all perfectly on the line. And what the R value actually does is it's kind of related to standard deviation, how spread out things are, the way they've constructed this formula. If R equaled 1, then all of these points would be on the exact same line. They'd be perfectly on it. And then that's the idea that hopefully you understand that. Let's skip to the fourth picture, second, third, fourth. This is a line with a negative slope. All that means is as time goes on, the y values go down. So going down negative linear correlation. Strong, not perfect. That one, if it was perfect, it would be -1. So I guess I shared that ahead of time. All right, so blah. Here are the things for this, and it's just how the formula is constructed. Ooh, do you like that, huh? I'm finding new. I knew these existed. They're just harder to find. These animations make it all exciting for the students. You should see them. Their eyes are just. It's like they're watching Guardians of the Galaxy at the movie theater. Almost the same. I'll just shut up now. All right. Oh, I'm worried about the next slide. Remember how these programs don't work together. Next. I knew it. Isn't that scary? That wasn't supposed to come up yet. That was supposed to come up at the end. Okay, so again, I'm not going to analyze this formula. I couldn't right now. I'd have to really delve into it to see how this comes up with this R value, but it does. No crying. I bet you like cat better now than this after seeing this formula. Okay, so the first thing you got to do is remember there's a bunch of coordinates. There's a bunch of x comma y's. So you find the sum of the x values. You don't have to put this in steps. You can put this comma, sum of the x values, that's sigma. If you understand what sigma x means, then just write find sigma x, sigma y, come on. I hit, oh, there, okay. Sigma y, find sigma x times y, so that means find x times y for each set of coordinates, and then add those products. That's the order. So it's not what we have in the parentheses there just to make a point. So you have to take x times y, each x value times each y value, and then add them, all of those. I break it down, but then someone, I'll tell you what they did as you're writing this stuff down. You shouldn't write all this, but you know it's already online, the PDF notes. But shh, over there. Can't talk while you're talking. Okay, so see, I lost my train of thought. These kids these days, I tell you, you know what? I'm going to get evil on someone here. I lost my train of thought. All right, next. Again, if you understand these notations, wow, that takes a long time. Square the x values, and then find the sum of those. Now you see how the color coding came in. See, this wasn't supposed to show up yet. Get outside. Get out. No, because he's not taking any notes. He doesn't do anything. He makes his comments back there, and then he bothers me. Get out. Get out. Okay? All right, right there. You're good. Okay, next. Seniors. All right? And then the next one. Oh, wait. Watch this. Get ready. Got to hurry up and write. I don't know why I picked this as my animation. Oh, it didn't start. I don't think it hit. Hold on. Okay, here it comes. Get ready. Are you ready for this? Boom, boom. Where is it? How come it didn't show up? This is stupid. Let me do this. Why won't it show up? What is happening? Is it because I kicked out that student? No, I let it. Sit down, sir. What is happening? Number 6 isn't coming up. We have the number 5 go away. Okay. 4, 5, right? Okay, here comes 6, maybe. There it is. Hurry up and write it. Then calculate R. N is the amount of coordinates. Did you get that? Okay, one more time. I think I hit the back button. I just didn't give it time. Get ready for it. If you're talking with your friend, where are your notes at? You don't even you don't do notes. Well, that's why you get to talk. I don't have to take notes. So I can just talk during Mr. S's notes because it's all about me. Doesn't matter if anyone else has to listen. Okay, now here comes the formula. I think. Why does the world hate me? All right. No. Hold on. There was supposed to be an animation. Hold on. That is not the animation I picked. All right, that's fine. Okay, now here it is. Are you okay over there? All right, so I tried to color code it to where these things all fall into place. This movie is way too long with all my animations. Okay? One student kicked out, another one moved. This is fun. So again, as you read this, I tried to color code even though that n flew by, but n is the amount of coordinates that there are, amount of data points. And then these all correspond to where these go, minus. All right, and sorry that maroon and red, they kind of show up a little bit better. I don't know why it didn't seem so good, but maroon was probably a bad choice compared to red. So I tried to color code the formula so you know where the spots go. So it looks daunting, but when we actually do this, I will talk about what someone fifth hour figured out. Not that first hour didn't, but they didn't share it with me. That they, the homework, some of them have like 10 coordinates. But what they did is they typed them in L1, the X's, and L2, the Y's. You got to be careful on this. But like this wasn't hard. Sum, I think, is in the probability menu. And then you could go out in the main screen and sum L1. And then press enter. Then you could sum L2. Then you could, I'm worried about X times Y, which is just L1 times L2. So you might be able to put some parentheses L1 times L2. I'm worried about that. You got to watch yourself, though, on this one. What they did was they did do L1 squared, and then it does list all the values squared in order. Then you can put it in instead of having to square them in your head. And then they did do, L2 squared, and then wrote down all the numbers, and then added them. I don't know. So at least there's something that you can do. But you got to be careful. If you try to type this, you might end up, doing something improper that you don't even know. And that's your fault. If you're going to decide to try to do this quick method of using that, it's your responsibility to type it correctly. I'm not doing that because what you could do, gosh, dog it. This is all supposed to come in order. Look at this. I just love the incompatibility of these two programs. It ruins everything. Ruins it all. So none of this is supposed to be anything that's color, anything that's on here. The only thing that's supposed to be is the chart. Arrgh. Okay? Very angry right now. But anyway, construct the scatter plot. Age of people compared to the percent that they donate. And then as these fly in, this is when they are supposed to appear. But the first thing was, and I'll leave this all up here because it's been ruined in class by the not being able to do these order things. I'm not going to tell anyone. No one will be able to help me, I bet. But if you plotted them, then, just accept that this is the plot of them. I'm sure you can do this. 42, 9. That's somewhere around there. I went up 1 through 10, and then I went 10 through 70, because 72 is our oldest age. And there's 72, 3. Blah, 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 blah. So when you do these coordinates and plot them, what can you expect for an R value? 1, 0, or -1? What would be the closest? You should understand that it's -1 is what we should have. But it already appears, so that question is ruined. Okay, so now this is what I was saying about what do you have to do? Well, you have to find the sum of these. So if you type this in L1 and L2, I still might put the chart and then just sum L1 and then put 336 down. Here it comes. And then I'd sum the Y's. That's not hard, though. But now it does get a little bit crazy. What I might do, that's sigma, ma'am. All right, and then what's x, y? Multiply them. So honestly, if you put these, this is not the animation I chose, by the way. It's even changing my animations. You could do L1 times L2 and press enter, and it will list it as a list of coordinates. Then if you just wrote them down, and then that might be the one you add by hand. Just a little worried about that. I think you could test it right now. I'll leave these notes up here if you wanted. You could try this, typing in the sum of L1 squared. Now again, I'm talking about if you put these values in L1 or put these values in L2 for Y. So if you did the sum of x squared, you might get that 19,458. So this is something when I leave the notes up here, you can test, would this be a way that I could do this to get these numbers? You still should identify and write those down. That's where people get into trouble. Not keeping track of their values and taking them slow. All right, and then magically this formula comes in again, maybe. And it's taking forever for it to come in. Why does it disappear? There. Jeez. Okay, and then you could put the numbers in the right spot. Oh, this was the worst incompatibility of notes with the movie making software. Yeah, pretty much. So I'm really disturbed that and we're still waiting for that animation to come in. There it is. And then let's see the sentence come in. Oh, wow. Did you see how far that was? And then it came in? That was kind of cool. Okay, so just as we expected something close to -1. You can get them back in now. I don't care if you go ahead. No, you have to. Okay, because I don't care if he interrupts me now. Okay, so it is close to -1, so we just say there's a strong negative correlation between age and percent of income donated. Okay, I don't know. Yep, gonna freeze it like I said. Just disgruntled that all that time I took on animation was ruined.